Most drilled wells underlie a more or less significant yield decrease during their operation time due to aging processes induced by a number of physical and chemical phenomena. Aging of wells can have different causes, such as material deterioration and corrosion, or physical damage and technical breakdown, buildup of mineral incrustation and bioclogging, or sand intake, damage by ground movement or earthquakes, or just simply decreasing aquifer yield. As almost all aquifers have a vertical hydrochemical layering, aging processes can be accelerated by elevated concentrations of incrustation building constituents and by mixing waters from different hydrochemical zones, by high pH value for ochre and high hardness for sintering, or by high nutrient supply and high flow velocities. In Germany, especially the growth of incrustation with 87% is the main reason for a well-specific decrease of yield. Iron and manganese oxides, hydroxides and oxyhydroxides are the most frequent mineral deposits, both in Germany and in the United States, as we can see here from the collected data documented by contractors. This focuses the attention on their formation as well as on their temporal and spatial growth. Microorganisms living in soils and aquifers, particularly the so-called iron bacteria, such as Gallionella ferruginea and Mare profundus ferrooxidans, draw their energy to endure from the oxidation of soluble bivalent iron to trivalent iron. This TEM picture A shows us the actual cell of Mare profundus in the process of extruding stalks composed of individual filaments. So this is the very origin of water well aging. The bacteria itself is a hardly visible tiny bean at one end of a long stalk. Picture A on top shows 2 months old twisted stalks of Gallionella and Mare profundus. At this stage, they still have a pristine filamentous structure, which we see in the detailed picture B. However, after 9 months, the same stalks in picture C show already a heavy iron oxyhydroxide impregnation. Over time, these soft metastable phases with high surface energy of this voluminous mass of iron 3 age into more stable phases with lower surface energy, finally turning into goethite. Here a picture of radial crystals, so-called beads, which serve as docking areas for new deposits. They in turn protect and laminate the old ones during this never-ending natural process. During the so-called Ostwald ripening, surface area, solubility and reactivity of iron and manganese oxides decrease, and at the same time insolubility together with crystal size increase. In normal hydrochemically layered aquifers, precipitation reactions take place primarily in the upper part of the screen, and as soon as it has been clogged, incrustation continues to grow downwards. A constantly increasing entrance resistance at an unchanged pumping rate leads to a higher drawdown, which, in the worst case, can expose the well screen. Well rehabilitation should be initiated when the yield has dropped 20% from the original value, as at this stage the performance can easily be restored at a moderate cost.